Welcome to RC circuits, sine waves, and instantaneous voltages. All right, so say we've got an RC circuit now. We're going to flip to a sine wave. In the previous videos, we were doing all square wave analysis. And we want to know, what's going on with this circuit at resonance. We know that at resonance, X of C should be equal to R. We know that the formula X sub C is equal to 1 divided by 2 pi times the frequency times the capacitance. And if we substitute out the R, if R is equal to X sub C, which it should be at frequency cutoff or resonance, we can substitute out the X sub C for the R1 in the formula. Now we can solve the formula for frequency cutoff equal to 1 divided by 2 pi R1 times C1. And this it should be review from previous semesters, but we know that at resonance we want to find the impedance. ZT is equal to R1 squared times X of C1 squared, and then the angle should be the opposite over the adjacent arctangent, and that gives us a ZT of 1.4142 k ohms if our R value and our X sub C are equal to 1 k ohm, and also an angle of negative 45 degrees. Now that we've got ZT, we can find IT, and our generator is our reference, so we're going to set that equal to 0 degrees. Divide that by our ZT, Vgen divided by ZT gives us an IT of 7.07114 milliamps at an angle of 45 degrees. Now we can find VR and VC by multiplying current times resistance. The resistor will be at an angle of 0, and that gives us a 7.07 volts peak at 45 degrees, and the capacitor, the X sub C, is at a negative 90, so we get VC also 7.0714114 volts peak but at a negative 45 degrees. And like I said earlier, this is all review. We should be able to find all these currents and voltages. So now we have the voltages. We have some phase angle relationships, but what if we want to find the instantaneous voltage or a particular voltage at a particular time or in relation to the other voltages? So we've got the V instantaneous formula is equal to V max sine of the quantity 360 times the frequency times the time plus or minus whatever phase angle we have, and that should give us the instantaneous voltage for each one of these voltages that we already know. So we know that the Vgen is our reference, and it is 10 volts peak, so we're going to put that 10 in for the max. We've got our sine, and then 360 times 1k was our frequency times whatever time we want, and that because it's our generator, it's at 0 degrees. VR1 instantaneous is the 7.07. That's the maximum voltage that we'll ever see across R1, times sine 360 times 1k is the frequency times whatever time we want to see, and we know that we should be leading by 45 degrees. And then the VC is the exact same thing, but it's lagging by 45 degrees. So here's an Excel spreadsheet where I've got the Vgen, the VR, and the VC as we defined in the previous slide, and time t in increments, and you can see each instantaneous voltage at those increments of time. And here are the waveforms graphed also in Excel, and you can see how they relate to each other instantaneously.